Hello. Welcome to the AOTO stand. This year, AOTO are co-partnered with Mo-Sys Engineering, who are in turn supported by AOTO Studio and Move. AOTO manufactures advanced LED technology, creating LED tiles with superior imaging qualities. In fact, they are providing the LED screens that you see here. AOTO has developed the industry's best scan rate of 1/6, the highest refresh rate of 7,680 Hertz, one of the widest viewing angles at 175 degrees, and a significantly higher light output of 1,900 square meters. In addition, the AOTO patented mini LED technology can achieve deep blacks and a wide color gamut in HDR mode. Mo-Sys is a leading innovator and manufacturer of virtual production technology. They are providing the LED content server VP Pro XR and the Star Tracker camera and lens tracking system. AOTO Studio is a real-time broadcast graphics technology company. They are providing the on-air graphics capabilities and the integration with the Mo-Sys LED content server. Move is a virtual studio, sports and events graphics design company. They are providing the virtual studio scene, like the one you see behind us, which is BBC's Tokyo Olympic scene from 2022. Over the last 2 years, LED virtual production has seen an explosion in adoption across TV, film, drama, commercials, and music videos. But in broadcast, LED walls have until now only been used for partial or 2D studio backdrops, or to display infographics in a regular studio. Now, the situation is about to change. LED walls are increasing in image quality while it's reducing in price. Key broadcast required features are becoming available, and so now it makes sense to look at an LED virtual production studio as a powerful, future-proof option to a traditional green screen studio, including news and factual programming. So for our demo here today, we're using 2 tracked cameras pointing at the AOTO 2.3 pitch LED screen, both equipped with Mo-Sys Star Trackers. While it's interesting to look at this space with the LED wall and cameras, actually, what's more important is to look at the output of the cameras on the LED wall here. If we pan camera 1, you can see the virtual graphics displayed on the LED wall changing in perspective. The inner image is called the frustum, and this is the field of view of the camera. So now we're going to pan the camera beyond the LED wall to show you how the VP Pro XR set extensions are working. So set extensions are augmented reality elements, and they can be utilized to give the illusion of a much larger virtual studio than the actual physical space will allow. And importantly, they allow us to extend the virtual studio without requiring additional LED tiles. So set extension, or XR, introduces a delay that now needs to be managed. The delay, of course, we're talking to is between the tracking data being output and the correct perspective of virtual graphics being displayed on the LED wall. Ultimately, this delay results in reducing the speed at which you can pan a camera. So too fast, the image will judder as the image will struggle to process and drop frames. VP Pro XR introduces just 7 frames of delay with 2 or more for the LED processor, meaning that it allows for a faster camera panning than a typical media server. This ensures that the set extension joins remain seamless during camera panning, and the LED display graphics update smoothly. Generally speaking, an LED virtual production studio can only display 1 camera's perspective on the LED wall at a time. Up until now, if you switch between 2 cameras, the LED wall graphics would lag 5 to 6 frames behind. On switching, you would see the new camera's view with 5 to 6 frames of the previous camera's virtual background before it switched to its own virtual background. Obviously, this is unusable for live or recorded broadcast programming. So uses Mo-Sys' new multicam feature for VP Pro XR. When we switch between camera 1 and camera 2, the LED wall change is synchronized with the camera switch. This means that LED multi-camera production is now possible using as many tracked cameras as required. Importantly, the camera switching is at full resolution up to UHD 4K, providing maximum quality to the LED processor. LED virtual production is powered by real-time photorealistic graphics from a games engine. In our case here, we're using Epic's Unreal Engine. The use of realistic photographics in broadcast isn't new, and we've been using them for more than 5 years. But for news and factual programming, graphics have traditionally been split between 3D photorealistic graphics used for virtual studio and augmented reality generated by a games engine, and 2D templated graphics used for lower thirds and data-fed infographics generated by a traditional broadcast graphics provider. Until now, it's been impossible to use lower thirds and data-fed graphics with a photorealistic virtual scene and have these on-air graphics recallable by a newsroom computer system using MOS protocols. If you look at the camera output LED screen, you'll see the results of the Mo-Sys and Arizo Studios collaboration. It is now possible to call lower thirds and data-fed graphics, both created in Unreal Engine, from a newsroom computer system using MOS protocols, and use them with Unreal Virtual Set. So Arizo Studio orchestrates the MOS calls, and VP Pro XR manages the virtual scene and graphics. These graphics are 2D, but they could equally be 3D. In our example here, we have chosen to have the lower thirds and data-fed graphics as AR elements, where they're combined in a mixer, but we could equally have them embedded in the virtual scene. What this means is that for the first time, it is now possible to use Unreal Engine for all of your broadcast graphics. This combined solution can be purchased from either Mo-Sys or Arizo, and Mo-Sys can additionally supply a complete LED volume package containing its combined solutions. Well, that brings us to the end of our presentation here. I want to go ahead and thank you for your time, and for more information, please speak to one of the AOTO's, Mo-Sys, or Arizo Studios team members that you see here on the stand. Make sure to have your badge scanned so we can keep you updated on all of our LED virtual production developments, and thank you. Enjoy the rest of your time here at NAB.